asking our three panelists to say their name and a little bit about them and where they work. So, Anat?
Okay. So, hi everybody. My name is Anat Zimmer, and currently I'm a postdoc fellow at the Fred Hutch Cancer Center in Seattle. I'm coming from Israel, where I did my bachelor degree, master's, and PhD. Then 6 years ago, I moved here to Seattle. I did my first postdoc fellowship at the ISB, Institute for Systems Biology in Seattle. And then 3 years ago, I moved to Fred Hutch. I'm a computational biologist, which means that I'm applying computational tools to study biology. Currently, we are working on blood biopsies to characterize and subtype cancer and fit treatment based on the blood test.
Okay, thank you.
My name is Geneva Schlepp, and I just graduated from the University of Washington with my master's of environmental engineering. Before that, I went to Washington State University, and I got my undergraduate degree in environmental engineering as well. And in the field, I've been really interested in wastewater treatment, so treatment of sewage. And I'm about to start my first full-time job at HDR in Bellevue, and I'll work on wastewater treatment, trying to work on some projects for renewable energy with biogas. Really excited to get started and talk to you all today.
Hi everyone, my name is Tiffany Tang. I'm currently a process engineering supervisor at Crane Aerospace and Electronics, as well as SWE P&W's current president, and that's the Society of Women Engineers. I'm originally from Honolulu, Hawaii, but I moved to Washington State for college. I attended the University of Washington, where I completed my bachelor's and master's in material science and engineering. At work, we're currently working on a bunch of really cool new products for Space 2.0, so low Earth orbit applications, space, deep space, and aerospace in general. So yeah, really excited to talk to everyone.
Okay. Thank you. So my first question for our panelists is, what or who inspired you to pursue a career in STEM?
I'll start again. So for me, I have two siblings that were in high tech. They studied computer science. It was the early 2000s, and there was a hype in high tech. So I knew that I wanted to go to that direction, something about computer science, technology. But I also wanted something that would be meaningful, not just code for billing or something like this, but something that will have an impact on the world. So I met a friend that was in bioinformatics, and I asked him. I didn't know anything about biotechnology, biochemistry. I didn't know what's the differences bioinformatics, and he gave me a really good advice. He told me to take the widest education that I can. So my bachelor degree is in computer science and biology. And he told me later on you can do the connection and apply the computational tools on the biology. And this is exactly what I'm doing. So that was my inspiration.
Okay, thank you.
My dad's also a civil engineer, and so growing up, I was really encouraged by my parents. Once they realized that I did like math and science, like very stereotypical for pathway to engineering, they just always encouraged me that I had a space in engineering and helped me to define where that space was best. So definitely my mom and my dad.
For me, a lot of it had to do with where I grew up. Growing up in Hawaii, there's a lot of really cool environments and, the beach and the mountains. Growing up, I really got to see a lot of conservation work and environmental impacts in Hawaii. So going into college, I actually thought I wanted to do something that could do either green energy types of things or environmental science or environmental studies. I ended up obviously going the engineering route, and that kind of happened by attending seminars that were open to undergrads, freshmen in college. There was a professor in the material science and engineering department who took essentially trash, shellfish, shells that, if you go to a restaurant, a buffet, it's like all the stuff you throw away once you've eaten your crab legs. He took that chitin and turned them into microneedles that could deliver really specific dosages at very specific depths in your skin, and life-saving stuff. So the idea of taking trash and turning it into something useful really, I guess, inspired me to pursue material science and engineering.
Okay. Thank you. So whatever you're doing right now, or maybe what you're going to start doing, in your case, Tiffany, what do you love most about your job?
Most about my job is that I get to work on so many different issues and like engineering challenges. Crane Aerospace is a pretty large company, but I work for the Modular Power Group, which is relatively small. And that means that we get to wear a lot of hats. And I'm sure a lot of companies, you'll hear kind of that same thing of many engineers wear many hats, because we're all really great engineers and capable of doing lots of things. But I guess it just means that it's never dull. Working on sustaining issues, working on new product that's going to go into space, I think is really cool. We work on things that go into aerospace as well. So, commercial applications. I think it's really cool that we work on things that touch everyday lives, and being able to see that is something that I really enjoy, and really enjoy my coworkers. And yeah, I just think it's a really fun place to work.
Okay. Geneva?
In civil and environmental engineering, since it's pertaining to people, the people I work with tend to be fairly nice, and because they want to help the environment, they want to provide things that everyday people like you and me, we rely on. So the thing I love most about my job are the people that I work with, and specifically being a student, I've participated in conferences and gotten to meet a lot of people in industry, and like, you hear that term, like building your network, but how it happens in real life is really a wonderful thing, and connecting with different people. And like Tiffany mentioned, like the interdisciplinary nature, I think you touched upon that. Like, you wear a lot of hats, so the more people you meet, the more connections you make, and it just is, I'm really early in my career, but it's budding into like a really exciting career full of wonderful people and exciting opportunities.
Okay. Annette?
So what I like the most about our work is that you get to be very creative. You need to solve problems, and you need to bring yourself and your creativity and out-of-the-box thinking. And also I like it that our work is very applicable and can really make a difference and impact in the world of humans' health. I also really like to educate others and pass the knowledge that I have to others, and communicate the science that I'm doing. So this is also part that I really like similar to what we are doing here today.
Okay. Thank you. What skills or qualities do you think are most important for success in STEM fields?
I would say number one is being kind to yourself, because you're never going to, even though we might think this, you're never going to know everything, and every day is a learning opportunity. And I think that a lot of people attracted to STEM were hard workers, big thinkers, but it's important to remember it's okay to ask for help, and it's okay to let yourself have a learning curve. Like, they call it a learning curve for a reason. So being patient and kind to yourself along the journey as you're growing into the career.
I think something else, and it kind of piggybacks on that, is being able to self-advocate. I think entering STEM as a female, hopefully you have advocates for you that are already there, but that may not always be the case. So being able to speak to your strengths, understand where you need to grow, and going to look for those opportunities to grow in those areas, just being able to be confident in who you are and advocate for yourself, I think is also really important.
I think that really important skills are to be curious and creative and motivated to do the work, because sometimes you just need to invest a lot, and it takes time till you see the fruits. So you need like to take a big breath and like be able to like run for long distances.
Okay. So how important do you feel mentoring is for women in STEM?
So I think mentoring is very important in STEM. Today I'm here with the Society of Women Engineers, P&W section. Mentoring is a large part of what we do because we think that having role models that look like yourself in the things you want to do is really important, and having someone that you can go and ask questions either formally or informally, I think is really important. It's a great way to knowledge transfer or share your understandings, your knowledge with future generations, and help guide future generations into STEM. And I think it's, like, even for me, like, I have mentors that I find really inspiring. And, you know, if I ever reach somewhere a path where I don't know what to do, I have mentors that I can always go to and ask them for their opinions. We may or may not agree all the time, but it's a great way to have like a sounding board and just a community that you know you can go to when you need help or when you've got questions.
Really benefited from mentors throughout my whole, I mean, like anyone can really be a mentor, and at any stage in your career. So it's not, oh, you only get a mentor when you're a student. Oh, you only get a mentor when you're first starting your job. Like my most senior people I've worked with have always talked about really highly of their mentors. So it never goes away. It's a wonderful like habit to start. And if it's not provided to you like really formally, you can always ask someone to be, that you look up to be your mentor. If you look, you can usually find formal programs, and I've really benefited from that, and just having an opportunity to spur discussions and talk to someone that's been in your shoes or been in a similar place, and you'll be surprised about what people with different backgrounds and like experience level, what they can bring to the table, and also not forget that you bring something really important as a, typically in mentoring, like the younger person, the mentee, or the less experienced. You have value that you bring to that senior person, so never forget that they're looking to you also to answer their questions.
I agree with everything that was said. I would just want to add that I don't understand why, I think that mentoring is important for both men and women, and I don't see how it's like more important for women. I think that like, even with these questions, there is a little bit of problematic to ask like what if mentoring is important for women. It's important for everybody, and everybody can benefit from it.
Thank you for that, yes.
So I agree. My first mentor with the Society of Women Engineers was actually a male, and like I thought he was really helpful. And it was at the University of Washington when I did it. But yeah, I agree. Like, for example, SWE isn't only for females, it's for males and females, and it's just like working towards equality. So yeah, agreed. Mentorship is great for everyone.
Just another remark on that, like the sentence that I have all the time in my mind is that if someone on Earth understood a concept or something, there is no reason that I won't be able to understand it and take part of it. It might take more time to learn. It might take different approaches, but the fact that I'm a woman or an immigrant or whatever doesn't mean if someone on Earth understood this or that the concept or something, I am capable of doing it as well. And I think this is something that should be in everybody's mind, men and women. Just go follow your dreams.
I will jump in. I have to remind myself really often that when I ask myself, why do we need Society of Women Engineers? Like, I'm an equal at work. My employers that I've had, it's like 50-50 men, women. I look at my departments and I feel like there's a lot of female representation. But then I remember that's just a true place of privilege, that I've been encouraged and brought up to believe that I have a space in engineering. And so until everyone, I have to remember that there are people that specifically need a space created for women, because not every industry is 50-50 or like equal. So I have to remind myself it's an important question to ask and like promote. But I agree that sometimes I question, like, man, is it really like now it's boys against girls, like Society of Women Engineers? And I like that you brought up, like, it's for everyone, but we want to make sure there's dedicated space so that we like not have to prove that we're good enough, because like I think that's pretty obvious that women are amazing, but maybe not to everyone. So important to have the space, but good. I really like the dialogue and what you guys brought.
I'm going to ask a kind of a follow-up question to that, and that's, well, as you're networking, or talk a little bit about your networking and how you found some of these mentors.
Really quick, so I'm not a mic hog, but one of the conferences and organizations I was a part of, they had a formal mentorship program. They were seeking undergrads to apply, and then it was like a 5-step, 5-week. You met with your mentors. You discussed like really, well, the thought was specific things, but it was very natural. Like every time we met, we would address questions I had. And then other than that, when you get into work, I think really good companies, they invest in their employees by making a space saying like, hey, we have like a certain budget. We want you to talk with your mentor. So it looks different everywhere, but other than that, it could be professors. I've had many professors that like beyond just office hours, you naturally are more inclined to chat with them, and they bring something that you're interested in, like job opportunities or research. So many ways that you can find mentors.
Yeah, I think similarly, I've been involved in formal mentorship programs. So like I kind of mentioned, SWE has a few formal mentorship programs that I took part of when I was a collegiate. I don't do that anymore as a professional, but there are, SWE at the national level has a official mentor-mentee program for students to connect with professionals that I just haven't had a chance to explore yet myself. But in my professional life, I guess, I am part of some other professional societies that are technical in nature, and attending those events and finding, honestly, people that I consider friends, but have also created a mentor-mentee relationship with, where it is just me asking them, you know, hey, I really want to do this within the chapter or within my career. I know you already have done this or achieved this goal that I have. Can we like grab coffee, grab a meal, and just talk about that? I think that's a really easy way to segue or start a relationship that I would consider both a friendship and a mentee-mentor relationship. So that's one way. And then also at work, kind of, I think you've touched on, just people that you work with. If there's a formal, you know, mentor program, that's awesome. But even if there isn't, I think a lot of the times companies will encourage you to set up meetings with, you know, coworkers that you may be interested in learning more about their roles or what they do or their background, and potentially being able to form a mentor-mentee relationship that way is also one that I know works well.
So in academia, I think one important thing is like going to conferences and present, and also present yourself. So if you go to a conference, take a look at the other presenters, the other professors that are participating, read about them, read about their studies, and then go and introduce yourself. If it's something that you are interested in, have like a small elevated pitch of introducing yourself, what you're interested in, why did you approach that person, So this is how I think the best way to create connections. And also in your department, in your institution where you are doing your research or study, present and also like go to other labs and ask what they are doing and try to make some connections.
Okay. So how important is the role of diversity and inclusion in driving innovation and progress in STEM fields?
So I guess in short, I do think it's really important having people from multiple backgrounds with different opinions, I think does create the best product. And when you're talking about diversity, I know here today we are looking at, female male diversity, but that's really not the totality of DE&I, right? It's people of all ages, people of all backgrounds, all nationalities, understanding that markets usually aren't super niche. What you want to create is a product that is accessible and hopefully useful for everyone. And I think having a really diverse team working on that end product is kind of how you get to a really great product that everyone can use.
I think that it's clear that when you have a diverse group, then you bring more creativity, more better thinking and everything. And everybody, like the diverse group can bring many different angles of thinking. This is like, there are many studies that showing that, and everybody kind of like know that. Unfortunately, I think that still, I know that in your place it's different, but I feel like that if we sit in a group, you can see still differences between if like a man is saying something or a woman saying something, unfortunately. So we know that diversity is important. There are like workshops and like the PIs and everybody are trying to make it equal with numbers and then have a diverse group. But in practice, sometimes not all the sounds are heard. So you still need to fight for your place. You still need to make your voice louder. Hopefully we won't have this question in the next years.
Okay. Before you set your microphone down, you mentioned PI, and I don't know that everybody here would understand what that is.
PI is the principal investigator, or you're basically the head of the lab. It's the professor that is like managing the lab.
Okay, thank you. Geneva, do you want?
Have much to follow up. Those were
I'm coming from, you have also many technologies that acquire massive amounts of information. You can now monitor people and have like lots of measurements throughout many you can do it like for long periods. So again, you get massive amount of information that with AI and proper storage and all of this, I think it's a very exciting era, and it might shed light on many questions that we currently don't even think about how it can evolve.
In my field specifically, some things I've loved seeing coming out, like in recent years, are like the inclusion of art with STEM. So trying to engage communities. I mean, specifically for civil and environmental engineering, you build things that people use. So when you can share that knowledge with like the greater public, I think that that's great. That like City of Seattle, they dedicate like 1% of a project to art money, and then bringing in local artists and trying to engage people and share. So it's not this mystery of, oh, what is engineering? It's like, well, this is what it is, and this is how we can share it all together. And beyond that, like the added benefit. So we're not just doing things just to do it. We want to make sure that we're thinking things through in a way that maximizes like our investment. Like how can we not only solve our issue that's at hand or the challenge at hand, but what other good can come of this? So thinking, like you keep talking about, curiously and creatively. So definitely like a cool shift happening, I think, in the field.
Yeah, I think there's so much new stuff going on, and I think this is kind of one of the hardest questions we've been asked so far in this panel. I think in my field at work specifically, I think Space 2.0 and exploring low Earth orbit applications, and even like things like Mars exploration applications, just everything in that realm right now is growing so quickly, and trying to figure out applications and how to get us even further and further out. But at the same time, coming up with things that are cheaper to, maybe make space tourism possible. That's all very, very interesting and growing a lot recently from like the space community. Something that I personally think is really interesting from like my materials background, though, is hybridization and electrification of like cars. I think that is something that there's been a big push for recently, and I think that will be really interesting to see where it goes. I do think there needs to be a lot of improvement in the life cycle of like batteries, for example, that are used in electric and hybrid cars right now. So kind of seeing where industry and academia will take us with new battery innovations and potentially like building an infrastructure for more hybrid and electric cars. Ties into like some civil and environmental stuff. Like, I think that's going to be really interesting for society as a whole.
Okay. Thank you. Well, question number 2, which I didn't ask you on purpose. What do you love most about your job? Oh, we did do that one. Okay. Okay, no, it's number 3. Sorry. What advice would you give to young women or any student interested in pursuing STEM fields?
So I think one advice would be to seize opportunities and widen your knowledge as possible. So be interdisciplinary and try to master like one field, like I don't know, computer science, math, something like this, but also widen your knowledge to other areas, physics, chemistry, biology, and then do the connections. I think this is very powerful. If you build your own unique skill set, then you'll be very valuable later on.
Okay, thank you. Geneva.
I have to give myself the confidence pep talk a lot. Like I said, I'm starting a new job, and I'll let myself get into this anxious headspace, like, oh my gosh, why'd they hire me? Why are they, like, so stupid? But I have to remember, like, one, it's great to have people around you that can build yourself up, but, like, also remember you can build yourself up. Like, remind yourself of, like, the steps that you've taken, why you're capable, and it's important to, like, check in with yourself. I don't think we do that enough, and, like, we're just go, 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 but, like, remember, like, oh my gosh, I bring a lot of value. We talked about diversity, like, what about me is valuable to the team? And if you have a good team, they're gonna remind you, like, not every day, but you'll get little, like, stepping points in your career where you're like, hey, you were amazing when you did this. So, like, cherish those moments and remember that you are just, like, you are awesome and you bring a lot of value. And I'm saying this also for myself to hear and remember.
Thank you.
I love what you just said. Had kind of talked about like self-advocacy, and I think that is really something that you should be aware of, like you might have to do from a really early stage and start practicing it, you know, maybe first with yourself, telling yourself that, you know, like when I got into my degree, like UW, I think now you are admitted directly into the College of Engineering, but that wasn't the case when I was in school. And just being like, yes, I do deserve to be here. I am as good as my peers, or better. Yeah, just being able to tell yourself that I think was super important. And then something that I found really useful in my just personal journey is that when I was in school, I kind of did something, I don't know, I guess like not super unique, but like I minored in political science because I had always heard the stereotype of like engineers don't talk well or like can't write well and things like that, right? Like we're all just technical jargon and don't have the capacity to do anything else. So, and I had kind of mentioned when I like initially looked at schools, I didn't know if I wanted to do environmental studies or environmental sciences because something that really interested me was like sustainability. And like it kind of ties into what was said about like looking at a bunch of different fields where I was like, you know, a lot of the times science and technology gets stalled or stopped in politics or just by regulation. So being able to kind of speak both languages, I thought has been super helpful, and it just taking classes that aren't typical STEM classes as well just grows your knowledge base and like your tool belt to work with in the future. So I would kind of suggest that. Just grow your tool belt as big as you can.
Yeah. So I'm going to time check here. Carrie, when are you supposed to start? At 15. Okay. So we will wrap up and thank our panelists. So Anat, Geneva, and Tiffany, thank you so much. They will be leading workshops, so you might see them again or you may not. So let's give them a hand of some applause. And I want my awesome boss to the microphone. This is Dr. Carrie Schroyer, Dean of STEM.
Thank you, Rachel. Thank you.
All right.
Yeah, you take your time. Yeah. Yeah, you do what you need to do. I'm not sure. Are we supposed to start? Because it doesn't seem like there's many people.
Well, they're in the other building. There's a whole bunch of them.
Okay. But this is the right place. Tell me when to go. How's that? I'll wait for Rachel. I'll wait. How are you all today? Are you good? Okay, good. Thank you. Are you excited about today? Good. It is pretty exciting, isn't it? How many of you think you want to go into STEM? Okay, good. I see. Good. You think so, maybe? Yeah, good, you all. There's a lot of things out there to go into. So, Rachel, tell me when you're ready, okay? Are we recording or are we not? Okay. Okay. I am introducing Gracie. Hi, Gracie. Okay, I'll wait. How's that? Yeah. Good morning, everyone. Let's try that again. Good morning, everyone. Thank you. That's awesome. Good morning. Thank you all for being here. We are really excited to host EYH again. So I just want to say good morning to all my colleagues, good morning to our guests, and most importantly, good morning to the brilliant young minds who are in the room. And I'm talking about all of you all. Look around. You are the brilliant young minds of the future. I like that smile. Good, smile. So welcome to our Expand Your Horizons event. It's an absolute honor to stand before you as we embark on this exciting journey of exploration, discovery, and empowerment. Today we come together to celebrate something truly extraordinary, and that is the boundless potential of women in STEM. And I should start by saying, my name is Dr. Carrie Schroyer, and I am the Dean of STEM. So once again, welcome. As I look around this room, I can't help but feel a surge of excitement and optimism for the future. Each of you represents a spark, a force of nature to set ablaze the world with your passion, your intellect, and your determination. Today, we have the privilege of delving into the vast and exhilarating world of science, technology, engineering, and mathematics, with more than 20 workshops led by talented, professional women working in a variety of different STEM fields. Many of these fields not only shape our present, but hold the keys to our future. And who better to lead the charge into this future than all of the brilliant young women in this room? Once again, I'm talking about you all. Look around, okay? You can do this. The theme of today's conference is Expand Your Horizons. And that's exactly what we're here to do. We're here to shatter glass ceilings, to defy expectations, and to forge new paths where none may have existed before. The path for women in science has not always been easy, but women have persevered, and the number of women getting STEM degrees has increased. Now, 45% of doctoral degrees in STEM are accomplished by women. It's amazing, isn't it? Okay, 45% of doctoral degrees are obtained by women now. However, there's more work to be done. Information from the Commission on Professionals in Science and Technology reports that women only hold 25% of the jobs in STEM. And this number is much lower in certain STEM professions, reminding us that women and girls still need encouragement, especially in the fields of engineering and computer science. With that said, we are privileged today to have a shining example of what's possible in STEM when determination meets opportunity. Our keynote speaker, Gracie Ermey, is not just a computer scientist. She's a pioneer and a trailblazer who is using artificial intelligence to revolutionize environmental research at Impact Observatory. How many of you are excited about AI? Anybody? How many of you are good? How many of you are scared of AI? A lot of us, yeah. Okay. How many of you are excited about environmental science? Yeah. So this is going to be a really exciting talk, and I'm so excited to welcome Gracie. Her journey is a testament to the power of perseverance and the power of believing in yourself. Gracie's story is just one among many, a beacon of hope illuminating the path for all of us gathered here today. She reminds us that no dream is too big, no obstacle too daunting when we dare to dream and reach for the stars. As we kick off this event, let us remember the importance of encouraging girls and women to study STEM, not just for today, but for the future. The world is changing rapidly, and it is up to each of you to shape that change, to innovate, and to lead with courage and compassion. The future belongs to those who dare to dream big and work hard to turn those dreams into reality. Let us remember the words of Helen Keller. Alone we can do so little, together we can do so much. Together, let us expand our horizons and lead and change the world. So please welcome Gracie. Come on up, Gracie.
No worries. Thank you for that wonderful introduction. I'm so excited to be here today with all of you. It's going to be a fun day, so I hope you're ready for a lot of STEM. And I'll just kick it off by, talking about my own career and all the ways that coding and technology and AI can be used to help make the world a better place. I'm going to talk a lot about myself in this, but I also want to get to know a little bit about you to start off. So raise your hand if, when I list a topic, you're interested in that. So, okay, raise your hand if you're interested in sports, playing sports, watching sports. Nice. Okay, a lot of us. Cool. How about music? Anyone into music? Yes. Cool. Me too. How about art? Any type of art? Making art, drawing, painting, anything? Nice. Okay. How about healthcare and medicine? Anyone think they want to go into those fields? Nice. Okay, a lot of interests. And of course, those are not all the interests that we all have in this room. But as I'm talking, I really want you to think about, and I will definitely emphasize, that all of these interests that you have can be combined with technology and coding and AI, and you can combine those things and do all of these things that you're interested in your careers as you move forward. I think I'm holding this way. Okay, cool. Figured out the clicker. Okay, so outside of work, so at work I do a lot of coding, I do a lot of technology stuff, but outside of work I have a lot of other interests. So I really love to knit. I made that sweater based on one of Mabel's sweaters in Gravity Falls. I have a lot of siblings, so they're in those top two pictures there. They're some of my favorite people. Welcome everyone, it's good to see you all. I also have a little dog. Her name is Margot. Shout out to Margot for being my guest test audience for this talk. She very attentively listened to me while I practiced this. And then I live in Paulsbo, across the water from here, with my fiance Danny, and we love to go hiking, camping, and stuff whenever we can. Okay. And just to make sure that we're all kind of on the same page with being a computer scientist, I'm a computer scientist, and I want to make sure we all understand sort of what a computer scientist does. When I was first getting into this field, I kind of thought that if you go into technology, you have to know like everything about all different types of technology. And that was really intimidating because oftentimes I would be like, I don't even know how to fix my printer when it's not working. So the idea of like having to know everything about everything was really intimidating to me. And sometimes I was like, I don't know enough to go into this field. But rest assured, something that was really relieving to me is that when you go into technology, you really do have sort of a specialization. So if you are a computer scientist, your work is, it's all about coding, which is writing instructions in a way that a computer can understand. So I'm at my computer a lot, I'm in meetings with my teams, there's a lot of collaboration involved in computer science, and we're writing code so that we can get computers to do cool stuff. On the other hand, we don't have to worry about things like the actual hardware that we're working with. So like the monitor, the keyboard, the computer chips, like we don't have to worry about that kind of stuff at all. We don't have to know how to fix it. We don't have to know how to build it. That is like a whole different area of expertise. So computer science really is just focused on like coding and building cool stuff with computers. So how did I get here to this job? Growing up, I didn't have any coding or computer science classes offered at all in my middle school or high school. And even if I had had those options available to me, I don't think I would have taken those classes because I really just thought, like, I'm not a techie person. I didn't play a lot of video games growing up. I thought you had to, like, be someone who builds computers in your garage in order to, like, be a computer scientist or, like, be a hacker in your basement. We've all seen, like, movies where hackers are furiously coding away in their basements, and that just, I didn't relate to those types of interests at all. I did love playing sports. I played a bunch of sports growing up. I was in band and played the saxophone all the way from 5th grade up through college. And I loved a lot of other subjects in school, but just computer science, coding, that was not, and technology in general was like not something I was considering at all. So then, to my surprise, I go off to college, and at that point, I had had really good STEM teachers in high school, especially math and physics. Those were two subjects that I was really excited about and had really great teachers who inspired me a lot to consider studying one of those subjects. Because of those interests, I was accepted to this program where I was required to take my first ever coding class. So I was 18 years old, had never written any code in my life, did not know anything about it, or like what it looked like or what it, the experience was like. And going into that first class, I was terrified. I was like, I'm gonna hate this class or I'm gonna fail this class, and I'll just get through it as fast as I can and like never look at computer science ever again. But to my surprise, that first class, we talked a lot about how coding and computer science are just this tool that you can learn to use, and you can apply it in all these different ways to help solve problems that you care about. And that really resonated with me because that was what I wanted to do with my life. I wanted to find a job where I could make a positive difference and help make the world better in some way. So I didn't know you could do that with technology, or I had just never thought about it in that way. So that was really intriguing to me. So I took some more computer science classes, I learned a little bit more, and I decided to study computer science. I majored in it, and then when I was getting close to the end of that degree, I was like, I don't want to get a real job yet, so I got a master's degree as well. But I went to Western up in Bellingham, and it was just an amazing experience, and I loved going to school there. And when I graduated, I still didn't know really what I wanted to do, but again, I still had that goal of finding a job where I felt like I was making a positive impact in an area that I cared about. And I found this really cool company called Vulcan, and they were building technology to help wildlife conservation. This was a concept and the combination of ideas that I had never known existed before. I didn't know that you could use technology in this way. And I got to work on some really, really cool projects there, all about, most of these projects, we would work really closely with a scientist who was studying some type of animal, some species, usually an endangered species, and we would learn all about their research and their process for studying these animals, and then we would help build them some kind of technology that would make their research easier or faster or more efficient usually in some way. So it was really, really fascinating stuff. I got to meet some amazing wildlife scientists. And one of my favorite projects I got to work on while I was there was this killer whale health metrics project. So who has heard of the southern resident killer whales? The J-pod, the K-pod, the L-pod, maybe you've heard about them in the news. Yeah, they are a really famous population of whales. They live basically in our backyard, right? They live in the Salish Sea, so that's the Puget Sound, and then all the way up into parts of Canada and down into parts of California. And they are severely endangered, so there are only about 75 of them left in this population. And there are orcas all over the world, different species of them, different populations of orcas. So this is just one of those. So there's more than 75 orcas left in the world. I like to say that, because sometimes that's a little bit, startling to hear. But it is still startling for this population, and that's why they're in the news a lot, because when they do have a baby, it's very, very exciting. So we worked with this scientist, her name is Dr. Holly Fernbach, and her research was all about taking a big drone, an octocopter with 8 arms, out. They would go out on their boat, and they would fly the drone over the whales and take amazing pictures like this one. And from these pictures, they're able to do these very precise measurements on just the pictures themselves and be able to get health assessments of each whale in this population. So it's really, really impactful work because these health assessments, they help us decide things like how far away boats need to stay from the whales. So different policies that impact the whales directly are really, these numbers help us write those policies, or help experts write those policies. So Holly's work is really, really cool. And what we were trying to do for her is to help her not have to spend so much time on the really tedious parts of her research. So when she would go out and fly the drone, she would take thousands of pictures just in one flight, and she would do many of these flights. Every time the whales are kind of in the area, she would go out and fly the drone. And then it would take many months to process all of those images and get to the point of actually having the health assessment numbers. So that's a lot of time between seeing the whales and then being able to like actually take action if action is needed. So my team and I built her some artificial intelligence software that could ingest all these pictures that she had taken and identify the whales in the images, which was pretty cool stuff. And then also estimate where to place these measurements on the photos. And this was all very like flexible. She could go in and use her expert eye and like correct everything that the AI was suggesting to her. But it was also very powerful because she didn't have to spend quite so many months processing these images. So really just shortening the time from collecting the data to taking action. This was another cool project. Instead of using photos to study animals, this scientist, Dr. Layla Saig, she was using audio recordings of dolphins to be able to study them. And Dr. Saig's research had involved recording these dolphins in Sarasota Bay, Florida for many, many years. And then she had discovered that these dolphins and all bottlenose dolphins make unique whistles. So it's called their signature whistle. And this signature whistle is different from all the other dolphins. So they can kind of tell each other apart based on this signature whistle. So she discovered this really cool piece of information and had been working then to learn more about them and their signature whistles. So she had like 35 years of audio recordings of these dolphins. And, how would you ever listen to 35 years worth of audio recordings, even if you had a big team of people trying to help you work through that and find all these dolphin whistles? So again, we built her some AI to automatically listen to these recordings, pull out the whistles that were heard, and then take its best guess at which dolphin it was hearing based on the signature whistle. So it was very cool stuff. And the idea was that we could then use this AI tool and have these recorders at different points around the bay where the dolphins live and be able to track their movements. So if we heard dolphin A's whistle over by this recorder, like we know that that dolphin passed through there. So we could kind of track their behavior, their movements based on like if some kind of environmental, like a red tide or something happened, like how did their behavior and their movement patterns change? So that was also pretty cool stuff. And then now I work at this company called Impact Observatory, and the work that I'm doing now is a little bit more focused on land conservation. Instead of looking at a specific species, we're kind of looking more at ecosystems and whole areas of land. So we build these maps. They're land use and land cover maps. So they tell you what type of land is at all different points in the area that you're looking at. And we build these maps for the entire globe. Every year we put out a new one. And so this is our 2022 map for Washington. So the different colors mean different things. Green is trees, orange is crops, red is built area, so things like buildings and cities and things. So these colors make sense for what we know about Washington, right? It's very green on the west side of the state. It's very red, a lot of city and neighborhoods and buildings around Seattle and King County. And then on the east side, it's a lot of crops, and that tan color is like grassland. So makes sense when you're looking at a big area like this, and it just kind of gives you a bird's eye view of what that land looks like. And so these are two maps of the area that we're in right now. I tried to capture as much of the area as I could of like where all of you are from. So it's hard to read the labels, but Edmonds is in there, Mukilteo's in there, Everett's in there. So it's kind of this wider area that we're in right now. And so imagine that you are someone who manages a really, really big area of land, like maybe a national park or like a huge forest. You can't go out and walk that entire area every day, certainly, but not even probably every month or like every few months. And so these maps can help you see your land from, again, a bird's eye view and see any unexpected changes that might have happened. So then you can like be more targeted about like, okay, this area looks kind of weird. Maybe we go send someone out to that specific area instead of having to monitor the entire area on foot or even in a vehicle. So you can it's kind of a fun spot the difference game. You can look at 2017 versus 2023 here and see if you can notice any differences that have happened to the land in this area over those years. There's not a ton of changes. If you notice something, you can raise your hand, or I can point out what I noticed. Oh, yeah. Hello, okay, cool. Okay, so you said the crops got smaller. That is a good observation, yeah. And that's like a change that we sometimes see because maybe cropland has been taken over by like a new neighborhood being built or something. Anyone else? I saw another hand, yeah. We built more cities, yeah. So there's more red than there was before. And again, that's like a really expected change, right? People are moving to the area, so new neighborhoods are going in, things like that. Yeah, those are great observations. And the way that we build these maps, or the reason that we can build these maps, is because of satellites. So satellites up in space, there are a whole bunch of them now, and a lot of them have cameras on them. So they are able to take pictures of the Earth down below and give us a snapshot of what does the land look like at that time when the picture was taken. So again, this is that same area that was in the map, but the satellite image version of it. And I'll zoom in a little bit to where we are right now. So that's Edmonds College, and you can kind of see these pictures aren't like it's a little bit blurry when you start to zoom in, so they're like not as high resolution as something like the images in Google Maps or something, where you can zoom in really, really far and see like your individual houses in great detail. But the benefit of these specific images that we use, even though they're a little bit lower resolution, is that we get new images every 7 to 10 days. So as we get new imagery in, we can build more and more updated maps of the area. So if you wanted to compare your national park from what it looked like last month to this month, we can build those maps as soon as we have new images of the area. So it's pretty cool and really powerful stuff. And it's helping a lot of people who are protecting ecosystems and national parks and forests and trying to keep the planet, as unchanged as we can. And the other thing that these maps can help us do is, well, just kind of some of the areas that we're trying to help using these maps. We can map things like natural disasters and the area before and after a natural disaster to kind of see the expanse of land that has been affected by that disaster. We can track things like deforestation. So this example here is in Cambodia, and there was a lot of tree loss between those two images in those 2 years. And we're kind of moving towards, instead of, like we did with the two maps, 2017 and 2023, you had to kind of scan the map and look for what the changes were. We're trying to really automate that process and be able to pull out, like, this is a change you should look at and care about, and trying to find and automatically alert people of, like, this is an unexpected change that you should look into. So that's kind of what the pink is showing in that map. We can look at sea level rise and coastline changes. We can see human expansion, changes in agriculture, which affects our food supply for all of us, and so much more. So we're always thinking of new ways that we can use these maps to help better protect the land. Okay, so that's a lot about how my career has kind of gone and the cool projects I've gotten to work on. And I wanted to also just touch on some lessons that I've learned along the way that I wish I had heard sooner. I probably did hear some of these messages, but maybe didn't like internalize them until more recently. So if you all hear one that resonates with you, hopefully you can internalize it today, and I hope help you as you're kind of moving through your own STEM journey. So I talked about this at the beginning, but computer science and coding and technology and AI, they're all being used more and more in every field. And so I think that that's really exciting because if you have some technology skills, then you can really apply those to any field that you're interested in. And it kind of unlocks the door for you to work in any field that you might be interested in. So even things like sports and music, those fields are traditionally a little bit harder to get into, but there are all kinds of technologists working in those fields. So maybe coding and technology could be kind of your way into those fields that you're really excited about. Another thing I wish I had internalized sooner is that you can still be a great computer scientist even if coding is not your #1 passion in the whole wide world. I had a lot of classmates in college who it felt like, they would spend all this time on our assignments, coding in the computer lab, and then they would go home and do more coding. And I was like, I can't look at a computer when I get home. I need to go outside and do the other things that I love. And I felt a lot of pressure for a long time, thinking maybe I'm not dedicated enough to this thing to be able to succeed here. But it was a real, a process to really realize that all those other things that you love are giving you relevant experience that you can take into your job someday. And it's just making you a more well-rounded person, a person who has different ideas than other people maybe who you're working with. And you do not have to spend 100% of your time coding to be a great computer scientist. I was a camp counselor in the summers throughout college when a lot of my classmates were getting internships at tech companies. I was like, I need to go outside and just be in nature and hang out with kids. So I did that in the summers. And I think that gave me really relevant experience, whether I knew that at the time or not. I learned so much in that job that I use every day. This one I want to embroider on a pillow or something and have it in my office all the time. I tell myself this all the time. Just because something is hard doesn't mean that you're bad at it. Especially when I was in high school, I was a real perfectionist, and I was like, if I am not immediately good at something, I don't think I should pursue it. I was really always tempted to just be that's not for me, And I think that that's an experience that a lot of us have. So with coding, it was not something that I was immediately good at. It was something that I really had to work at to learn. And that was that in and of itself was really hard, just persevering through that temptation to be this is too hard and I'm gonna give up. So I'm really glad that I pushed through that because I'm doing really, really cool stuff now that I'm really excited about. And so I just want you to remember, as you're going through all of your classes, sometimes it might seem oh, this subject is seems like it's really easy for everyone else and it's really hard for me. That is probably not the case. I'm sure everyone is struggling at different points, but also that does not mean that you are not also good enough to be there. So just keep that in mind and tell yourself, think back to this when you're having a hard moment in a class. Just think about, just because it's hard, that doesn't mean that you're bad at it. Community has also been a huge, huge thing in my computer science journey and my STEM journey. As I was going through my first computer science classes, it's already hard enough to learn a new skill like coding, but also a lot of my classes didn't have a lot of other women in them, so that's another barrier, that you have to sort of talk yourself into overcoming in some cases. It can be intimidating to walk into a room and be like, oh, no one here looks like me. Maybe I'm not supposed to be here. So what was really important was to find the people who I did feel like I related to in my classes, men and women. I had a community that was very diverse and amazing. And we all, the sort of thing that we did for each other was we encouraged each other and we helped each other get through those hard points where we were like thinking about giving up. We sort of brought each other along the way. So a lot of those people are still my really, really good friends to this day, and I still call them when I'm like, my job is so hard, I'm having a hard day, and they've just been really, really great. So I've continued to like add people to my community, and I think you all are creating community by being here today. So this is, it's just a really powerful thing that we can do together. And then finally, just finding role models, I think, is a really, really great way to help yourself as you're figuring out what you want to do. Learning about someone who has a job that you are interested in can be really helpful to give you ideas of how you might get there someday. You definitely don't have to take the same path that anyone else has taken, but maybe you take pieces of this person's path and pieces of this one and forge your path as you go. So I think that finding people you look up to is really, really helpful. And I'll leave you with this question, which is, what problem do you want to solve? You all have unique ideas, different from anyone else, and those ideas are really important, and the world really needs to hear them. So maybe coding, is a tool that you can add to your pocket as you go along and solve big problems that you're interested in. And I hope that we all maybe get to work together someday on those big problems. And I can't wait to see what you all do. So thanks for listening. If you have any questions, I'd love to hear them.
Thank you, Gracie. How many of you really enjoyed that conversation? Excellent. So one of the things I asked you all when we started was how many of you were interested in artificial intelligence? Let's do it again. How many of you are interested in artificial intelligence? How many of you are interested in environmental science now? Yeah, I see a few more hands because that was pretty exciting, wasn't it? So we do have time for a couple of questions, and I really want to encourage, are there any questions for Gracie? This is a really good opportunity for you all to sort of get a better understanding or ask something that may or may not be exactly related to. Yeah, go ahead. You want me to say it? Okay, go ahead. And
What did you do in high school to like get the
Okay. Yeah. She didn't want to use the microphone. Oh, okay. Okay. So the question was, and this is for Gracie, right? Okay. What did you do in high school to get into this field? Excellent question. Thank you. Do you want to use this one?
Yeah, so like I said, in high school, I was not considering this field at all. I didn't even know what it was about, right? And I didn't know anyone who was a technologist or worked in computer science. So it was hard to imagine what those jobs might look like and how I might get there. But in high school, I took a lot of math classes. I took physics classes. I basically took as many different like science and STEM classes as I could. And I think that really prepared me, even though I didn't know what I was necessarily preparing myself for at that point. But I also was like, I still pursued all of my like music classes and like art classes as much as I could because I was interested in those things as well. So I think exploring all of your interests in high school, keeping yourself open to what might come and what you might, eventually pursue is a good way to go.
And I'm going to add to that as the Dean of STEM. And just one thing I would encourage you all to do, if you're remotely interested in anything STEMmy, take math. Don't stop taking math, okay? Because math is going to be an important component for most STEM areas. Continue taking other things as well, but don't stop taking math, okay? Any other questions? Yeah, okay, I'm going to run up here. All right, do you want to yell? Okay, you can yell, please go ahead. What projects are you working on now?
That's okay.
I'm getting my steps in.
You are, yeah. So right now, I'm really focused on how do we automatically detect changes that are happening to the areas that we're monitoring. And so it's really broad. Like I might be looking at like images of a flood one day and then like images of a wildfire and like figuring out how do we really quickly like find those changes and map them and let people know, this area has changed so that people can be aware and take action if needed.
Okay, does anybody have one more? Oh, excellent. Yeah.
What was the toughest thing you overcame in this career?
The toughest thing I overcame in the career? Yeah, that is a good question. I think the toughest thing has really been a lot of my own internal monologue. As I was first learning to code, I already felt like I'm behind everyone else. And that certainly wasn't the case. A lot of people had never coded as well. But sometimes the people who are really loud in your classes and asking the most questions are like the people who are, like, oh, I've been coding for like 10 years and I have this, it's more of a comment than a question, those type of people. And that was really impacting me, I felt like, and just making me feel like, maybe this isn't the right place for me. So I've had a lot of imposter syndrome kind of as I've gone through my career. And so learning to, not let those internal voices stop me from pursuing things that I'm interested in has been a challenge, but very worthwhile to overcome.
So I was wrong. We have time for one more question. Who wants it? Oh, yay, somebody from the top. Okay. I've been told I have to have the microphone over here so everybody can hear. So I'm running this up to you. Here you go.
Where do you work now?
Yeah, I work at a very small startup called Impact Observatory. And the headquarters are in Washington, D.C. So obviously I can't commute to Washington, D.C. every day. So I work from home every day, which is really fun. My dog loves it. So it's the best.
Now I want her job. She gets to work from home. How about anybody else? Alrighty, you all. So we are going to wrap this up now. I want to thank everybody for being here. I also want to, one second, you all. I want to acknowledge Dr. Amit Singh, who stopped by before to welcome all of you to this event. Once again, he is our president of the college, and he wanted to say hi and welcome and thank you for being here. And mostly thank you to Gracie. Thank you.
Thanks.
Enjoy your day, everyone.